Hey guys, so I have approximately 8 minutes until my lunch starts, and I love lunch, so we'll see if I can get this video done in 8 minutes. Today we're going to be talking about a concept called molarity, and what molarity is it tells us how strong a solution is, or how concentrated a solution is. Scientists want to measure the concentration of their solution so that they can know how strong it is. If your concentrated solution is too strong, it's too concentrated, it's too saturated, then you can weaken your concentration by adding water. That's called diluting something. So a dilute solution is a solution that has a low concentration because you added water. So I'm going to add that here. A low concentration because water, or you added more of your solvent. A concentrated solution means that there's a lot of particles dissolved in the solvent. Lots of solute particles in your solvent. Okay, so let me show you an example of how we calculate molarity. So the formula for molarity is moles of solute, or your particle, divided by liters of your solution. Molarity is a measurement of concentration. It's a number measurement depicting concentration, okay? So how do we calculate the molarity of a solution? We use moles of solute and we divide it by liters of solvent. Okay, let's look at the first example. The first example, we're not given moles, we're given grams. So we're going to want to convert this gram number to moles. And we're not given liters, we're given milliliters. So we're going to have to do two conversions before I can plug it into the formula. If I take 2.3 grams of NaCl and I dissolve it into 250 milliliters of water, what's the molarity? Well, to convert grams to moles, I take grams of my solute over 1, and I'm essentially going to divide by the molar mass. So what's the molar mass of NaCl? Well, to solve this problem, I'm going to have to add the molar mass of sodium to the molar mass of chlorine. The total molar mass of Na plus Cl together is 58.44. So I take 2.3 and divide it by 58.44, and I get 0.039 moles. Okay, so that's going to go on the top, and now I need to convert my milliliters to liters. To convert milliliters to liters, you can divide by 1,000, or what might be easier is all you do is move your decimal 3 places to the left, and then you'll get liters. So these are my two givens. Remember, molarity is moles over liters, so I take my moles of my solute and I divide by liters of my solution. So I do 0.039 divided by 0.250, and I get 0.156. And the unit for molarity is capital M. Capital M. I'm going to draw that. After you do moles divided by liters, you get capital M. That stands for molarity. Okay? That tells me how concentrated my solution is. Now let's do another example. If I give you 0.33 grams of NiNO2 dissolved in 200 milliliters of water, I know I still have to convert milliliters to liters and grams to moles. Okay? So the molar mass for NiNO3 to get that, I have to do 1 Ni, I have to do 6 O's, I have to do 2 N's, and I have to add them all together. And that molar mass, when I add them all together, is 182.724 grams. So to get from grams to moles, I do my grams number over 1. I divide it by the molar mass, which was right here. So 0.33 divided by 182.724 is a really small number. It's my answer is 0.0018 moles. Okay, so that's my moles number. Now I need liters. 200 milliliters is the same as 0.200 liters. So I take 0.0018 moles divided by 0.2 liters, and I get 0.009 molarity. Okay, now let's look at this bottom one. This one's a little bit different. Remember, molarity is moles divided by liters. Okay. Here I'm given my liters. I just have to convert, And here I'm given my molarity. So I need to solve for moles. So let's go ahead and fill in. My molarity is 0.35. I'm trying to look for moles. And my liters, when I convert 125 milliliters to liters, I get 0.125 liters. And to find moles, I need to multiply both sides by my liters, and then I get my moles. So I do 0.125 times 0.35. That gives me, so I have this many moles in a molarity of 0.35 and a volume of 125 milliliters. Okay, so that's how we calculate molarity, concentration. The other thing we're going to learn about how to calculate is how to calculate how much water we should add if we want to dilute the molarity, if we want to weaken the concentration. Okay, the purpose of diluting a solution is to make it less concentrated. All right, so sometimes if you get if you make lemonade and you make it really, really, really strong, you add water to dilute it, right? So it's not as concentrated. So the formula for diluting is you have molarity, your original molarity, you multiply it by the original volume, and then that should always equal the final molarity times the final volume. Okay, so we need to underline and label all our givens. We have 22.5 milliliters, and remember, volume always needs to be in liters, so I'm going to convert milliliters to liters every single time. So this is really 0.0225 liters. Remember, move the decimal 3 places to the left to get liters. Okay, so if I have that many liters of, this is my molarity 1, and this is my volume 1, of a 2.0 molarity stock solution. So these guys are both of my V1 and my M1. I have those. It says that this particular compound is diluted to 0.250 liters, right? It's diluted to that, so this is my V2. What's the final solution? So I'm looking for M2, okay? So I'm going to take my numbers, I'll just plug them into my formula. So V1 is, well, let's start with M1. M1 is 2, right? And I'm going to multiply it by V1, which is 0.0225. And then I'm looking for M2, and then I'm solving for V2, which is 0.250. So in order to solve for M2, I'm going to simplify this side first. So 2 times 0.0225 gives me 0.045. Okay, so I've simplified it. Ah, there's the bell. Now it's time for lunch. So to get my second molarity, I'm going to divide. So I'm going to divide the side that doesn't have my variable by the side that does have my variable. Okay, so I move 0.25 over to the other side. And my molarity, my second molarity, is 0.18. So did I dilute it? I started with a 2 molarity and I ended with a 0.18 molarity. So I diluted it, right? I made it a lot less concentrated. Okay, so we have one more example here. Let's do together before I go and I eat a bunch of food. I have a 500 milliliter 1.2 molar solution. Those are all my V1 and my M1. Now my V1 is in milliliters, so let's change that to liters. It's 0.500 liters, by the way, because you move the decimal 3 places to the left. I want to make this molarity solution, so this is M2. How much water do you add? Okay, so technically it's not asking for the total volume, it's just asking how much do I add. Right now, let's just solve for V2, and then I'll show you how to figure out how much water you add. Okay, so M1 is 1.2, V1 is 0.500, M2 is 0.020, and we don't know what V2 is. So let's solve for V2. I'm going to simplify the left side. I multiply them together to get 0.6, and then once I do that, I'm going to divide this side by 0.02 and divide the other side by 0.02, and I get 30. My volume at the end is 30 liters. So let's think. At the beginning, my volume was 0.5 liters. At the end, it was 30 liters. So essentially, to figure out how much water you add, it's a subtraction problem. So in order to figure that out, you're going to subtract V1 from V2 to figure out how much you have to add. So I take 30, I divide it by 0.5, and I get 29.5 liters was added. All right, that's it. Y'all have a great day. Bye.